statistics. Okay. So it is 6:30 now, so we shall start the lesson. First of all, let me do a quick introduction about myself. I'm Teacher J. Okay, so this is my name, and this is my phone number. So if you have any questions, just feel free to WhatsApp me through this number. Now over there, that is our teaching assistant, Xixi. Xixi, today's task is to write down the lecture notes for you. So during the class, if you don't have time to write down all the lecture notes, you can check our TA's lecture notes. Alright, now finish talking about myself, let me get to know about you. So you are Jaden, you are Wyatt, and you are, sorry again? Kirsten. Okay, sorry about that. Okay, now today we'll be talking about an important topic called factors and multiple. See here? Factors and multiple. Now for factors and multiple, I believe most of you have learned it in school. So this will be a very important topic tested in your WA1 exams. So later when I'm explaining, please pay attention. Before the lesson, I still want to introduce some class rules. Now for the students, later when I'm explaining, because I don't want you to miss any important information, just please put your pens down when I'm explaining. Okay, eyes on me. I'll give you some time to take note after the explanation. And secondly, later if you have any questions, just feel free to raise your hands before you ask. Okay, and that's all for the students. Now for the parents over there are also some rules. First of all, please turn your phone to the silent mode. Secondly, please refrain yourself from walking in the classroom and also walking out of the classroom. Especially walking in the classroom and out, because this might disturb the students. Thirdly, please don't talk to each other. And fourthly, please don't answer my questions. Alright, and that will be all. Now, let's take a look at today's topic, factors and multiple. First of all, let me give you some worksheets. So later, each of you will receive 2 copies of the worksheet. One is for you to do during class, and another one is for you to redo after class. Okay, here you are. Oh, and 1 copy I'll give you to your parents. Later, you can ask for your parents for the copy. Okay, right, here you are. Jaden. Okay, these 2 copies for you. Your vice parents. Yes. Okay, so let's start today's lesson. First of all, let's do a quick revision about factors and multiple. Okay, now for example, if I give you a multiplication, 2 times 3 equals to 6. Now class, can you tell me where is the factors here? Kristen? 2 and 3, they are called the factors for number 6. So that means if a whole number times another whole number give us the result, these 2 whole numbers, they are called the factors of the result. Okay, now Wyatt, can you tell me, are there other factors for 6? 1, 6, perfect. Because 1 times 6 also give us 6. So the factors for number 6 are 1, 2, 3, and 6. Let me write this down here. The factors of 6 are 1, 2, 3, and 6. So you see, to find out all the factors of a number, you should split this number to the multiplication forms. Okay, now Jaden, can you tell me how do we find out the factor for number 8? All the factors. 1 times 8, perfect. 1 times 8 gives us 8. And 2 times 4, excellent. 2 times 4 also gives us 8. So, is that all? Okay, that's all, right? So, all the factors for 8 are 1, 2, 4, and 8. So these are the factors of 8. 1, 2, 4, and 8. So you see, in conclusion, to find out all factors of a number, you split this number to the multiplication form. Now, let's observe for these 2 number lists. Are there any number in common? So what's your name? Dylan. Okay. Dylan, can you tell me, for these 2 lists of numbers, are there any number in common? Which number are in common?
1 and 2.
1 and 2, excellent. So let me highlight this. Okay, so you see 1 and 2, oops, they are in common. Now, 1 and 2, they are the factor for both 6 and 8. So they are called the words of 6 and 8. Let's say why. Can you tell me for this 1 and 2, they are called the words of 6 and 8? The factors, not only factor, they are the common factor of these two numbers, right? So these are called common factors. Call it in short CM, common or CF, common factors of 6 and 8. Now in the common factors, there are some factors they are the least number, there are some factors they are the largest. Now normally we should focus on which common factor at most. Kirsten? 2, why 2? This is the highest common factor, right? So normally we'll focus on the highest common factor. Now in short, we'll call it HCF. In this question, this 2, this is the highest common factor. So in this question, it is 2. Now, if we try to focus on highest common factor, this time, let me give you an example. How do we find out the HCF, the highest common factor of number, let's say 12 and number 15? This time, maybe Jaden can tell me.
1 time.
Okay, first of all, we try to find out the common factor for these two numbers, right? So how about let's first list down the factors for 12 and 15 respectively. 1 times.
1 times 12.
Okay, 1 times 12. What else factors are there for 12?
2 times 6.
2 times 6.
3 times 4.
3 times 4. Perfect. Anything else? No, there's nothing else. Then how about for 15? This time maybe Dylan. 1 times 15. 3 times 5. Perfect. And are there anything else? Nothing else. Okay, so let's try to observe here. These are all the factors for 12. These numbers are all factors for 15. Are there any number in common? Wyatt? 3. Okay, let me highlight this. And 1. Among them, which is the highest common factor of them? 3. Perfect. So 3 here, this is the highest common factor. Alright, now finish recall about this factor. Let's take a look at another concept. Again, 2 times 6. Now in 2 times 3 equals to 6. So 2 and 3, they are called a factor for 6. Now 6 is called the what of 2 and 3? Kirsten? So this number 6 is called a what of 2? So remember, there's a concept of factor and a concept of multiple. So that concept is multiple. So you see, if this 2 times a whole number give us a result, this result is called a multiple of this number 2. Okay, let's recall, how do we find out a multiple of a number? For example, how do we find out a multiple of, let's say, number 4? Wyatt? Divide the 12 by 2. We try to find out all the multiples of 4. So,
Then you just then you list.
can you tell me one multiple of 4?
2.
2. Okay, you see, 4 times a whole number give us the multiple of 4. What number can this be? Maybe 1? Okay, let's say if it is 1. What is the result here? 4. Okay, so the first multiple of 4 is 4. Then how about this one if we change it to 2? 8. Perfect. Can you give me some number else?
16.
Okay, just follow the order, okay? So after 2, it is 3. What is 3 for? 12, okay? Can you give me another one?
16.
16, perfect.
20,
20, 24. Okay, very fast response.
28, 32, 36.
Okay, there's no space to write it down. So I just leave it as 3 dots, okay? But very fast calculation. Okay, now, Jaden, can you tell me how to find out, let's say, multiple of 6?
6 times 1.
Okay, 6 times 1 equals to 6. How about 2, 6?
12.
Please see in the front. Please see in the front. Okay.
12.
12, okay. Anything else? 16, excellent. 16. Let's think about it again. 3 times 6 give us the number. 18, perfect. 24, excellent. 30. Okay, I'll just leave it here. There's no more space. So I just leave 3 dots over here. So you see, in conclusion, to find out the multiple of a number, you times this number with 1, 2, 3, 4, and so on and so on. And the list continues unlimited. Okay, let's observe in these two lists of numbers. Are there any number in common? Sorry, what's your name? Lucius. Oh, okay. Lucius. Can you tell me, are there any numbers in common in these two lists?
12 and 24.
Ah, 12 and 24. So the 12 and 24, they are in common. So that means 12 and 24, they are both a multiple of 4 and multiple of 6. So we should call this 12 and 24 the word of 4 and 6. Dylan? Common factors. Think about it again. This is a word of 4 and what? Multiples. Excellent. So these numbers, they are called the common multiples of 4 and 6. Common multiples. So in short, it is CM. Now for common multiples, there is a smallest common multiple, and there are unlimited common multiples. Normally, we'll focus on this smallest common multiple most. So you focus on this least common multiple. Now in short, we call it LCM. Okay. So in conclusion, to find out all the factors of a number, you split this number into multiplication form. Now to find out the multiple of this number, you times this number with 1, 2, 3, 4, and so on and so on. Okay, now finish about this revision. Okay, now let's try out a word problem related to the factors and multiple. Let's try out question 1. I'll give you 2 minutes, 3 minutes to try it out. Here you are. This one is for you to do in class, and this one is for you to redo. Okay. Is parents here? Oh, okay, I'll give one to your parents. Okay, give your parents. Okay, so you are this is the one for you to redo.
Thank you.
Okay, time's up. Everybody, eyes on me, please. Okay, let's take a look at this question together. At a fun fair, every second child gets a cotton candy, and every sixth child gets a cup of bubble tea. Which child is the first? Okay, the first child to get both a cotton candy and bubble tea. Okay, now to better understand this question, how about let's draw a graph to depict this situation. The question says there are some number of people here. Okay, let me draw some child. And then it said every second child gets a cotton candy. So let me highlight some label here. Let me give some label. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so on. Okay, now Kirsten, can you tell me if every second child gets a cotton candy, for this number of child, which child will get cotton candy? 2, okay. Let's get 2, 4, 6, and 8. Okay, so they get the cotton candy. Okay, similarly, if 6th child gets the cup of bubble tea, Wyatt, can you tell me which child here will get the bubble tea? 12. Okay, if every 6th child, are there any child that is in front of 12, before 12? Yeah, the 6th child is the first child to get a bubble tea. So the answer is obviously this one. The first child who gets a bubble tea and a cotton candy together is the 6th child. But this is a very straightforward way to draw the graph. But when the number of the child get larger, this is not very easy to solve it. So now let me introduce to you a more general way. Okay, let's observe. If every second child gets a cotton candy, so to get this cotton candy, the number of child is to satisfy which condition? Jaden, later I tell you. So can you tell me first, which child get the cotton candy? The second child, and what else? The fourth child, sixth child, eighth child. Now, what are the characteristics of this number? 2, 4, 6, 8. Of which number? Excellent! They are all the multiple of 2. So to get a cotton candy, the position of this child should be the multiple of 2. Now, similarly, to get the bubble tea, this time, let's say, Lucius, can you tell me, to get the bubble tea, the number of the child should satisfy which condition?
Multiples of 6.
Excellent! It should satisfy the multiple of 6. So this should be a multiple, this is multiple of 2. This is a multiple of 6. So the position of this child, if you get both the cotton candy and the bubble tea, it should satisfy these 2 conditions. So the position should be both the multiple of 2 and the multiple of 6. So that means there should be a word of 2 and 6. Jaden? Common factors? Think about it again. Excellent. So because this is a multiple of 2 and multiple of 6, so they are the multiple, the common multiple of 2 and 6. But not only the common multiple. We are trying to find out the first child to obtain. So that is the least common multiple. The LCM of 2 and 6. How do you find out the LCM of 2 and 6? This time, let me see.
These are the multiples of 2 and 6.
Excellent. Now let's try to list down. So multiple of 2 are 2, 4, 6, 8, 10. Okay, I just stop here and let's read stop here. Then how about for the multiple of 6? 6, 12, 18, okay, 24, and so on and so on. There are 3 dots here. Now can you tell me what is their least common multiple? 6, perfect. this 6 is the smallest common multiple. So in this case, the LCM here, this common multiple is number 6. So the sixth child is the first child who obtained both the cotton candy and the bubble tea. Alright, now let's do a quick revision about this question. In the question, we are given two different intervals, right? And we're trying to find out the first overlap of these two intervals. And then what should we find out, Kirsten? Find LCM, the least common multiple. Okay, let me write down in the summary here. So in summary, now if you're going to find the first occurrence, the first overlap of different intervals, then you'll find their least common multiple. Okay, please say it. What's your name?
郑家豪。
嘉禾. Okay, can I find your name here? Okay. If you can't find, you can write down the back and then your phone number. Okay, let's continue. So we have talked about this question. You find out their least common multiple. Now, can you write down this summary next to question 1? And also write down these lecture notes in your handout. One more. Oh, because one I give to your parents. Later you can ask your parents for another one. And then after you write down these lecture notes, try solving this similar question over here under your question 1. Okay? I just changed some numbers here. Okay, you have already done these notes, right? Okay. I haven't done it. If you have finished writing down these notes, try out this question. I made some modification in the numbers. So try out this question later, I'll explain. all written down the notes, right? Can you erase now? Okay, time's up. Now let's take a look at this question. So for this question, we'll just skip join the models. Then let's go directly to find out their least common multiple. Okay, see, every fourth child will get a cotton candy. So that means to get this cotton candy, the position of this child should satisfy which condition? Dylan? Fourth multiple, perfect. To get a cotton candy, it should be a multiple of 4. Alright, similarly, to get the cup of bubble tea, it should be a multiple of what number? Why? See, every 6th child gets a cup of bubble tea. So, to get a bubble tea, this position of the child, it should be a what? 6. And other numbers? 12. So, what are the characteristics for this list of numbers? Okay, you see 6, 12, 18. This is 6 times 1, 6 times 2, 6 times 3, 6 times 4. They are all the word of 6. Excellent. They are all the multiple of 6. So to get the bubble tea, you need to be a multiple of 6. And this time, we should find out the first child to get the cotton candy and the bubble tea. That means their least common multiple of 4 and 6. So we shall find out the LCM, least common multiple of 4 and 6. Okay, very fast response. But let's solve it step by step. This time, let's check. How about we first list down some multiple of 6 and then we check if it is also a multiple of 4. You see, let's list down some multiple of 6 here. This time, Kirsten, can you tell me what are the multiple of 6? Just name one. Okay, 6. And then we check, is there a multiple of 4? No. So let's continue. What are the another? 12. Okay, the next one is 12. Is there a multiple of 4? Yes, perfect. So we find out the smallest common multiple is 12. In this case, it is 12. So while solving this question, I saw most of you have listed down a lot of multiple of 4 and 6. That's of course workable, but it's very time consuming. So when you try to solve this question, I suggest you can start from one multiple, list down one, and then you check if it's a multiple of another. And then list down another one, and then check. So in this time, you see, we only need 2 types. Okay. So finish about this question. Now let's take a look at a very similar, not very similar, another question here. Okay. Now let's read the question together first. Mr. Tan wants to cover a floor measuring 24 meters by 32 meters with square tiles of the same size. Given that he uses only whole tiles, find the largest possible length of each side of one tile. Okay, to better understand this question, let me draw some graph here. Now the question says we are given a rectangular floor here. The length over here is 32 meters. The breadth over here is 24 meters. Now, we are going to cover this with some square tiles. Some square tiles over here. Now, we don't know exactly how many square tiles are there. But in the end, they are going to cover all this floor. Similarly for the vertical line here. They cover all this floor. We want to find out the largest possible length of each of these square tiles. How should we approach this? Class, any idea? Okay, no worries. Wait.
2 times 24.
2 times 24.
I mean 32 times 24.
32 times 24, that gives us what? Okay, let's take a look at this together, okay? You see, for this horizontal line, there are some number of tiles. Now, each tile's length is L. So L times the number of tiles should give us what number? Why? Okay, you see? The length of each tile, this is L. L, L, L. There are some number of L here, and the last one is also L. So the number of tiles times L should give us what number in total? L is the length of each tile. The length of each tile. The breadth. Which one are you talking about? This vertical line or horizontal line? Excellent, horizontal line. So that means this L, the length of each tile, times the number of the tile horizontally should give us 32 meters. Now, if L times a whole number give us 32, L is called a what of 32? Let's say, Lucius. This L is called a what of 32? Multiples. Think about it again. Let's say 2 times 3 equals to 6. 2 and 3, they are called a what of 6? Excellent, the factors. So you see, this L, it is a factor of 32. Let me write it down here. L is a factor of 32. Okay, similarly, let's observe vertically. Vertically, the length of each tile is also L. There are some number of tiles vertically. So L times the number in each column should give us what number? Jaden? You see, this is L. This is L. There are some L here, and the last one is also L. So each L times the number of tiles vertically should give us what number? Excellent! 24. So L times a whole number gives us 24. L is a what of 24? Excellent. L is a factor of 24. Let me write it down again. L is also a factor of 24. So L is both a factor of 32 and a factor of 24. So we call this L a what of 32 and 24. Jiahe. You see, L is a factor for both of these numbers. We call this L a what?
Common factor.
Excellent, the common factor of these two numbers. Okay, now not only the common factor, we're trying to find out the largest possible length. So the highest common factor of 32 and 24. Now, let's try to find it out. First of all, let's try to find out some factor for 32. Dylan, can you tell me? 1, 1, 2. Okay, how about let's try to bring it into multiplication form. So what times what give us 32? 1 times what number give us 32? 1. Okay, 1 times 32. This will give us 32. So these two, they are all factors. Other factors? 2. 16. Okay, perfect. Anything else? How about let's try 3? No. How about 4? Later I'll call you. But 4 times what number? Oh, so give us a reason. Excellent! 4 times 8 also give us 32. Let's think about, are there other numbers here? How about 5? 6? No. 7? No. 8. Oh, we have to find it. So these are all the factors for 32. Now, let's try to find out some factors for 24. Okay, why? 1 times 24. Wow, very fast calculation. 2 times 12. What else?
4 times 6.
4 times 6, but before 4, are there other possibilities? 1, 2, how about 3? Is 3 also a factor? Okay, I'll just skip instead.
Yes.
Yes, 3 times what? 8, perfect. So don't miss that. These are all the factors for 24. Okay, now let's try to observe. Are there any common factors here? Kirsten? 1, 2, 4, okay, perfect. 8. Okay, so what is the highest common factor then? 8, perfect. So here, 8, this is the highest common factor. So in this case, it is 8. And the largest possible length of each side of one tile is just 8 meters. Alright, now let's take a look at question B. Everybody, eyes on me please. Later I'll give you time to take notes, okay? We want to find out the number of tiles that are needed to cover the floor. So we now know that the length of each tile, this is 8 meters. This is 8. This is also 8. Now, let me ask, let's say, Lucius, can you tell me how many tiles in total are needed? How do you know it's 12? 32 divided by 8. This will give us what? Divided by 8 will give us 4. So in each row here, there are how many tiles? 4 tiles, perfect. And then let's check for vertically. How many rows are there? 3 rows. How do you know it's 3? Excellent. So this vertically, each line length is 8, equal to 24. So 24 divided by 8 will give us 3 rows. So in total, there are 3 times 4 equals to 12 tiles. Okay, now let's do a quick summary here. First of all, please put your pens down. Listen to me. Later, I'll give you time to take notes. Okay, so you see, in this question, we are given 2 different lengths. One horizontal, one vertical. And we are going to use a same length here to fill out these 2 different lengths. Then, you find out what? Why? Yeah, so to use one same length to fill up the 2 different lengths here, we're trying to find out their what? Yes, but first of all, we try to find out their common factors, right? We try to find out a common factor to fill up these 2 lengths. So you see, in summary, to fill up the 2 different lengths with the same length. Now you find, first of all, the highest common factor. Alright, now if you understand this, can you write down in your handout here in question 2 the summary and the working process for these 2 questions? I will give you 2 minutes to write down and later I'll check. Tiles each row and You still got 1 more minute to write down the notes. So please be faster. Okay, time's up. So if you have not enough time, you can check our TA's lecture notes later. Okay, so now we shall dive into a new topic here. Okay. Now to introduce this topic, let's take a look at an example first. This time we're trying to find out a number. Now this number, when divided by 3, has no remainder. When divided by 4 has also no remainder. We're trying to find out the smallest number that satisfies these two conditions. Okay, now first of all, let's check. If the number divided by 3 has no remainder, that means this number is a word of 3. Let's check, Dylan. A factor of 3? Check again. Multiple, yes, this number is larger than 3. So that means this number, it is a multiple of 3. Okay, similarly, if divided by 4 has no remainder, Wyatt, can you tell me this number should be a word of 4? Also a multiple, excellent. The number is also a multiple of 4. So this number is a word of 3 and 4. Kirsten? Common multiple, perfect. So the number is a common multiple of 3 and 4. But not only common multiple, we're trying to find out the smallest possible number. So Kirsten, it is a what common multiple? Smallest. Also call it least common multiple. Least common multiple of 3 and 4. So I'll just give the step for finding out their least common multiple. So in short, 3 and 4's common multiple is 12. Alright, now let's take a look at another example. This time, similarly, the number when divided by 3 has a remainder 1. When divided by 4 has a remainder 1 also. Again, we're trying to find out the smallest possible number. So any idea, Lucius? Okay, no worries. Let's check it again together. You see, if a number divided by 3 has a remainder 1, that means what? That means this number can consist of some number of 3. See, some number of 3. And what's the last number, Lucius? If divided by 3 has a remainder 1, it contains some number of 3, and the last number it should be always what? Okay, no worries. The last number it should always be a 1, right? Because you divide by 3 has a remainder 1 here. Okay, similarly, this number it can also be represented as this 4. So that means it can consist of some number of 4. And 4, the last number it should be what, Lucius? 1 also. Okay. Now let's think about this. If there is no this remainder, we know the result is 12. But now there is a remainder. So let's think about how can we remove this remainder. Let's see. Jaden? Can we just remove the remainder? Okay, let's think about this. If we minus 1 to this number, if we do a minus 1 to this number, then this 1 has been eliminated. Now you check it out. So now, after eliminating this 1, is there a multiple of 3? Didn't? Yes. Then how about, is there a multiple of 4? Yes, also. So after minusing this 1, this number, it is a least common multiple of 3 and 4. Least is because we don't find out the smallest number. So we know that this number is 12. That means what? This number, after minusing 1, gives us 12. What should this number be, Jason? 13, very good. You see, this number, after minusing 1, gives us 12. So this number is 12 plus 1 back equals to 13. Okay, so you see, in this case, we call this type of question the remainder problem because there is a remainder over here. So the general idea for this remainder problem is to convert it to a multiple problem like this. So if you have the same remainder, you minus this remainder to get the multiple problem. Now let me write it down here. So in the remainder problem, now you try to convert it to the multiple problem. Now in this scenario, if they have the same remainder, okay, so if they have the same remainder, then you minus this remainder to obtain the multiple problem. Okay, now let's take a look at another example here. This time, again, this number divided by 3, but it has a remainder 2. If it is divided by 4, it has a remainder 3. Any idea how to find out the smallest possible number here? Let's say, Jacob. Okay, no worries, let's list down first. So the number divided by 3 has a remainder 2. That means this number, it can consist some number of 3. And what is the last number? It divided by 3 has a remainder 2. So after a list of 3, the last number should be a what? You see, if it divided by 3, the remainder has a 1. So after a list of 3, it still have a 1 more, an extra 1, right? So if divided by 3, it has a remainder 2. So what is the actual number here? Jacob? 2, yes. So after divided by 3, it has a remainder 2. Similarly, after divided by 4 has a remainder 3. What does that mean? This time, Dylan? Okay, so it means it has a list of 4. And the last number is 3. Okay, this time, again, we try to convert it to a multiple problem. But does it have the same remainder? Right? Can we follow the previous method to solve this question? Previous question, we minus the same remainder, right? Because there is the same remainder. But in this case, they have no same remainder. So if we can't do minus, are there other operations we can do? Can we try some addition here? Okay, you see, this is a number, right? If we add 1 to this number, first of all, if I add 1 to this number, will this number be a multiple of 3? This is the original number. If I add 1 to it, will it be a multiple of 3? Yeah. Now after adding this 1, will it be also a multiple of 4? No? Yes, so because it's 3 plus another 1, give you a list of 4. So after adding this 1, this number 8 is a word of 3 and 4. Let's say Kirsten. The common multiple of 3 and 4. So we know that the LCM least common multiple of 3 and 4 is already 12. Now this number after plus 1 give us 12. What is this number, Kirsten? 11, very good. So this number is 12 minus 1 equals to 11. Because this number plus 1 give us 12. Okay, so you see, in this case, they don't have the same remainder. But if we add 1 to this number, here this 2 becomes 3. This 3 becomes 4. Now, so we call this one the complement. If they have the same complement, you add this complement to obtain the multiple problem. Okay? So in the second scenario, if you have the same complement, you add this complement. Okay. Now, can you try out a similar question over here? Let's say a number when divided by, let's say, 5 has a remainder 1. When divided by 6 has also a remainder 1. How to find out the smallest possible number that satisfies these two conditions? You have 1 minute to solve it. You can solve it next to question 3. Below your question 3. Just understand and then also this question. The number divided by 5 remainder 1, divided by 6 remainder 1. The smallest possible number here. I'll give you another 30 seconds. Sorry. No. Oh, how do you know it's perfect. That's the answer. Okay, excellent. Okay, let's take a look at this question. Alright. So you see, the number divided by 5 has a remainder 1. It means this number consists of some number of 5, some number of 5 here, and the last number is what, Tucker?
1.
Okay, the last number is a remainder 1. Similarly, 8 divided by 6 has a remainder 1. It consists some number of 6 over here, some number of 6, and the last number is also 1. Okay, so let's think about this. The number, it can be represented in this form. It can also be represented in this form. We try to convert it to a multiple problem so that it is easy for us to find out this number. How can we convert to a multiple problem? Any idea? You see, this extra 1, we try to eliminate it, right? So we try to minus this 1. So let's think about this. If you minus 1 to this number, this 1, it has been eliminated. So now, this number, is it a multiple of 5? You see, after minusing 1, this number becomes this one, right? Sorry? It becomes smaller, yeah, if you remove 1. This time, the number consists only 5 here. So is this number a multiple of 5? Yes. How about multiple of 6? Yes, also. So after minusing 1 to this number, it is a common multiple of 5 and 6. And also, the smallest common multiple. So this number after minusing 1 is a least common multiple of 5 and 6. So what is the least common multiple of 5 and 6? This time let me see our y. 30, okay. So this number after minusing 1 gives us 30. What is this number, Kirsten? 31, perfect. So this number after minusing 1 is 30. So the number should be 30 plus 1 equals to 31. Alright. Now I think you have understand this. Let's take a look at the word problem over here. Okay. Now let's read the question together first. Let's take a look here. Eddie and Mel picked some strawberries. If they counted by threes, there was 1 extra. If they counted by sevens, there were 6 short. Do you know at least how many strawberries they picked? Okay, first of all, let's check the first constraint. If they counted by threes, there was 1 extra. What does that mean? How can we represent it in an equation? Kirsten? Excellent. So that means after the number divided by 3, it has a remainder 1. Now similarly, if it counted by sevens, there was 6 short. What does that mean, Lucius? How do you know it's remainder 1, not 6? Excellent. You see, this is 6 short. It means if you have a list of sevens, the last number, this number, it is 6 less than 7. So a number that is 6 less than 7, it is number 1. So the remainder here is 1. So divided by 7 has a remainder 1. Now take note, when I write down here, I do not include an equal sign here because the quotient is not known. We only know the remainder. So if you write down the notes, do not include an equal sign here. Okay, so now this number, it should satisfy these 2 conditions. And also it is the at least, so the smallest number. Now let's take a look here. How do we find out the smallest number of strawberries they picked? This time, I will give you 2 minutes to think about it by yourself. And try to solve question 3. Get done so fast. Let's take a look. So the number is perfect. And how's the last question?
this question how it's okay? Push to right now. Like that in question. Trying to find out at least how much number is it. Which is some question sheet. Now that one is the hint for you. Because see divided by 3 there was 1 extra. That means this number when divided by 3 is 1 extra. So that means that's how we now divide by 3. That's how this question.
Yes.
Okay, the last question.
Okay, time's up. Now let's take a look at this question. Please put your pens down and eyes on me. Okay, the question says if divided by 3 there was 1 extra. So number when divided by 3 has extra a remainder 1. Also divided by 7 has a remainder 1. So how should we solve this question? This time let me ask, let's say, Jack, any idea? Any idea? So you see, this is again is a remainder problem, right? So can we convert it to a multiple problem without a remainder?
-1.
Minus 1, okay. Minus 1, this number is what? If we minus 1, we remove this remainder. Now, is there a multiple of 3? Yes. How about multiple of 7? Yes. So after minusing 1, this number is a what? Of 3 and 7. Yes, it is a common multiple of 3 and 7. So you see, this number, it can consist of the number of 3, and the last one is 1. It can also contain a number of 7, and the last one is 1. If you minus 1 to this number, you are just removing the last one here. So now, after minusing 1, it can be multiplied by 3, it can be divided by 7. So after minusing 1, this number is a common multiple of 3 and 7. But not only common multiple. We try to find out at least how many. So what common multiple? Jaden? Try to find out at least how much. At least is the smallest or the largest number. You need to pick at least how many strawberries. So that is the small number or the largest number. Small is very good. So not only the common multiple, but it's also a least common multiple of 3 and 7. So to find out the least common multiple of 3 and 7, I'll just skip these steps. This is value 21. So this number, after minusing 1, give us 21. What is this number? Maybe Jaden again. 22, perfect. So this number will give us 21 plus 1 equals to 22. Okay, now let's take a look at another example. this time, let's say a number when divided by 6. The number when divided by 6 has a remainder 3. When divided by 7 has a remainder, let's say 4. How can we find out the smallest possible number here? Now, first of all, let's observe. In this case, does it satisfy these two scenarios here? Yes? Does it have the same remainder? No. How about the same complement? What is the complement here? This one. What is the complement in this condition? Kirsten? Plus 3. Then how about for this condition? Plus 4. Plus 4. Okay, it is also plus 3. Okay. The complement. 4 plus what give us 7? 4 plus 3 also. So what does that mean? The number, if you add what number, give us the common multiple. Say Lucius. That's 3, perfect. You see this number, it consists of number of 6. And the last number, it should always be a 3. Also, it can be represented as a number of 7. And the last number, it is a 4. So if you plus 3 to this number, now for this number, is it a multiple of 6 now? Joshua? After plus 3, is this number a multiple of 6? Yes. Then how about, is it a multiple of 7? Also yes. So after plussing 3, the number is a word of 6 and 7. Excellent. So you see, this number, after plussing 3, is a common multiple of 6 and 7. So for sure, I'll just skip the step. It is 42. And then this number plus 3 gives us 42. What should this number be, Dylan? The number is plus 3 gives us 42. What number plus 3 gives us 42? Is that 39, perfect. So this number equals to 42 minus 3, which will give us 39. Okay, so that will be all for today's lesson. For question 6, I'll leave you as extra practice for you. No, not practice. Question 4, sorry. Question 4, I'll leave it as extra practice. And then, let's do a quick revision about today's lesson. In today's lesson, we have learned about some word problems related to factors and multiples. Now, in the first question, you still remember? In this question, if we are given different intervals and we're trying to find out their first overlap, what are we finding here? Why? The common multiple, and also it's the least common multiple, right? The first one. Okay, and also let's take a look here. In this question here, if you are given two different lengths, and you are going to fill out these two lengths with the same length, square with the same length. So what are we finding in this question? This time, Kirsten? The length of the size is a word of this 24 and 32. Yes, the common factors and also the highest common factor. Okay, so I think that will be all for today's lesson. Now you will be doing an after-class quiz to test on how you understand today's lesson. So it will last for 15 minutes. So if you finish in advance, you can let me know and I will mark your paper. Okay, here you are. And if you finish full mark, you will be awarded a card. So for the card, you can exchange the gift outside the door. Okay. For a certain number of cards, you can exchange for the gift outside the store. Yeah, you can start now.